Hello Priscilla, so you were asking me on the phone just like 5 seconds ago how to work a certain math problem that had radicals in, or that had fractions in a radical. So this is for my beautiful sister Priscilla, yay! Alright, so I'm going to teach you how to do this with the example that you gave me, okay? So, you gave me the example of the square root of 8/18. So it looks like this, right? Is that what you were talking about? Alright, now I'm going to convert this. I'm going to change it so that it looks like something else. It equals, this is just another way of rewriting it. I can rewrite it like this, right here. So this, this right here changes to this right here, okay? Now, I'm going to rewrite it another way. I'm going to take this square root of 8, and I'm going to simplify it. And I'm going to take the square root of 18, and I'm going to simplify it. So, I know, I'm just going to make like a little, I'm going to do it down here so that way you can see, okay? So, I'm going to create a little box. This is how I do my square roots. I make a tree. So I put my square root of 8 and I start my branches. What times what equals 8? 4 times 2 equals 8. Ta-da! Then I make a branch off of each of those. Okay? Other than the number times itself, or the number times 1, what equals 2? Well, there's nothing, so I can just erase that branch. There's just 2 times 1 that equals 2. So that is called a prime number. It can go no further. But 4 can 2 times 2. So I write 2 times 2 like this. Okay. Now 2, 2, and 2. I have 3 2s. They're all prime numbers. They can't be simplified any further. So I circle a pair of 2. So this pair of 2 get married and they move outside the house. The house is my square root. So these two 2's get married and they go outside the house. But there's still one 2 that's at home. So I'm going to put that 2 in home. Okay? So I just simplified this thing. So let's just for example say that I had another 2 somewhere. Then I would then have 4 2's, which means that I would have one set of 2 and another set of 2. So then there would be 2 times 2 on the outside, which would be 4, and then there would be nothing on the inside. But that, of course, is not how this problem worked out. This problem worked out with 3 2's, meaning I take 2 2's and put them here, and then I put 1 2 inside the house because 1 has not left home yet. So that is how I simplify the square root of 8. It is 2 on the square root of 2, like so. Okay, now for this square root of 18, I'm also going to go to my little side notes here. Square root of 18, and I draw my first branches. Okay, so what times what equals 18? How about 6 times 3? 6 times 3. Okay, now 3 is a prime number. 3 times 1 equals 3, but nothing other than 3 times 1 equals 3. Okay, so, but 6, 3 times 2. So I'm going to write 3 times 2. Like so. Okay, so now I have 3 times 2 equals 6, and then I have 6 times 3 equals 18. Which ones are going to get married? The 3 and the 2? No, because they're not the same. 3 and the 3 are going to get married. And they're going to move outside the house. So I circle my 3 and my 3. And I put 3 outside the house. 3 is now outside the house. Like so. But I still have this poor little 2. 2 is always left behind, you see? No, not always, but a lot of times. So 2 is here, so 2 goes back inside the house. And I think you do know how to simplify radicals, but I'm just going over it just in case you don't. So now I know that the square root of 18 is simplify to 3 on the square root of 2. So I'm going to write that, sorry, I'm doing this with the not on mirror image, so that way it comes out as right way to you. So I'm going to write it up here, right there, 3 on the square root of 2. Okay, so you see how I went from the square root of h over 18 to the square root, or 2 times the square root of 2 divided by 3 times the square root of 2. Now, I'm going to show you how you can do this 2 different ways, alright? After we get to here, okay, to this part right here. Now, this is the first step we're going to go on. I'm going to rewrite the problem just below it, so that way I have a fresh new line. 2 on the square root of 2 divided by 3 on the square root of 2 is equal to, or I'm not even going to put equal to, just that. Alright, now it's a rule, a mathematical rule that you cannot have a radical in the denominator, and I have a square root of 2 there. So in order to get rid of a radical, what you need to do is multiply by that same radical, because any radical times itself is just like the number without the radical. So the square root of 1 times the square root of 1 is equal to 1. The square root of 2 times the square root of 2 is equal to 2. The square root of 3 times the square root of 3 is equal to 3. The square root of 196 is equal to the square root, or times the square root of 196 is equal to just 196. And on like that. So I'm going to, what you multiply in the denominator, you have to multiply in the numerator. So I'm going to go ahead and write that out now. Multiply by square root of 2, square root of 2. But you don't so say the top number, say this number up here, 2 on the square root of 2, was like 2 on the square root of 5. I wouldn't want to multiply the bottom and the top by the square root of 5, because you can have a radical in the numerator. You just can't have it in the denominator. So whatever the radical is in the denominator, I want to multiply by that one. So 3 times the square root of 2 times the square root of 2 is equal to 3 times 2. Because square root of 2 times square root of 2 is equal to 2. So 3 times 2 is equal to 6, of course. Alright. Next, I'm going to say 2 times the square root of 2 times the square root of 2 times the square root of 2 is equal to 2 times 2, because the square root of 2 times the square root of 2 is equal to 2. So 2 times 2 is equal to 4. So I'm right 4. So I now have as my answer 4 divided by 6 is equal to, way up here, square root of 8 divided by 18. But this can still be simplified, because we both know that 4 and 6 have are common factors, which is 2. So divide by 2 on both sides. 4 divided by 2 is 2. 6 divided by 2 is 3. And I get my answer as 2/3. Right here. Now you may be saying, hey, look at this and look at this. Look at this and look at this. That's 2/3. That's 2/3. And that leads me to the second answer. The second way to get this answer. You can just say square root of 2 divided by square root of 2, or I'm going to rewrite it down here. 2 times the square root of 2 divided by 3 times the square root of 2 is equal to, and so what I'm going to do is right here, all I have to do is divide out square root of 2 divided by square root of 2, which is equal to 1, because any number divided by itself is 1. See, so how I just made that 1. So 2 divided by 3 is equal to that. Same answer. Same answer. Alright? Now the reason why I showed you this step first is because it's not often that you'll have the same radical in both the numerator and the denominator. Most of the time you'll have like I said, 2 on the square root of 5 divided by 3 on the square root of 2, or 2 on the square root of 16, or well, no, not 16, of 16, that would be 4, but 2 on the square root of 18 divided by 3 on the square root of 2, that type of thing. So so it's not often that you'll have the same radical or whatever. So that's why if you have it like this, where you can just divide out square root of 2 divided by square root of 2, or square root of 3 divided by square root of 3, then you can just go ahead and divide it out, put it as 1, 2 over 3. But if not, then you can do it this way. And it's none of it hard at all. So that is how you do that. if you need another example, I would be happy to show you. I didn't realize that this thing has already like 10 minutes, but love you, Po. Have a wonderful, wonderful day and a wonderful week. Bye-bye.